All right, so this is just part two. So the first part, I only showed two Gauss elimination ones, right? Just a regular XY, two equations, two unknowns, then XYZ, three equations, three unknowns. Here's another three equation, three unknown ones. So this will take us a little bit, but I want to show this one because it does end up with many solutions, and the way you write that answer is a little tricky. All right, so we start with, let's write this as a matrix. So 2, -3, -13, 14, 3, -8, -30, 28, 1, 2, 4, 0. All right, so we do a line or dotted, whatever way. Like I said before, we usually see it dotted, but it's a line on your notes, so either way. Okay, so what is the order we have to go in order to keep our zeros in the right place? We go this way, then this way, being careful that we use 2 with zeros if we need to keep a 0 in a certain spot. So let's start with, maybe we can multiply the bottom one by -3 and get a 0 here, right? So this looks easier than these two. So let's start there. So we'll take -3 times row 3 plus row 2, and we'd like to replace that on row 2 because we want the 0 to start here. 0, 0, 0. All right, then we'll do that step. So all right, -3, that ends up being a 0 right there. And then -3 times, which row are we doing it by? By 3. So that's going to give me -14 because it's -3 times 2 is -6. -6 minus 8 more is -14. Okay, then we're going to go 4 times -3 is -12. -12 plus, what is that? A -30 is -42. 0 times anything is 0. 0 plus 28 is 28. So we only changed the one row. So this is still 1, 2, 4, 0. This one's still 2, -3, -13, 14. Okay, now we have the first 0. I would like a 0 to be right under that one. So I am going to multiply the bottom row, row 3, by -2. And add it with the top row to get the 0 in that first column. So I can't use this one because it's a 0, but I can use this one and this one to get the 0 here. So that, and then I'm going to add that to row 1, and I'm going to replace it on row 3. So we're really only changing that row 3, so it's 0 at the beginning. So -2 times the bottom, and then add it to the top. So that's a 0. -2 times 2 is -4, minus 3 more is -7. -4 times, or sorry, -2 times 4 is -8, minus 13 is -21. 0 times anything is 0 plus 14 is going to give me 14. All right, then the other two rows are going to stay the same. All right, so here's where we're at right now. Okay, I'm looking at this, and we have to get this one to be a 0. So here's where I'm looking at this. These are ugly numbers, ugly numbers, ugly numbers. Can we divide the bottom row, every single number, by something to kind of make them prettier when we're trying to get that 0? Yeah, so let's do row 3 divided by what? -7. Then it becomes positive, positive, negative. I mean, it could just be 7. I don't know why I put -7. It doesn't really matter. And then row 2, while we're at it, 14 goes into 42. This should have been a 28. How did I write 20? I was like, it goes in pretty. No, that's a 28. I wrote 20, but 0 times anything plus 28 is 28. Okay, so then we could also do row 2 divided by a negative 14. This will just make the numbers prettier. I can't do anything on the top row to make those prettier. So the top row stays the same because 13 is weird. Nothing's going to go into 13 or 3, really. Then the next row divided by negative 14. So 0, 1, 3, negative 2. Bottom row, 0, 1, 3, negative 2. This was totally optional, but sometimes your numbers just get so hideous. If you can divide every single thing without making a decimal, that'll make it prettier to work with. So now we know we want this to be a 0, way easier to work with. Now we already have a 0 in this row, so we have to use the one that has a 0 in that same row so that when I add these two together and get the 0 here, I don't add and get a number here. So if I used this one and this one, these would add to a 2, and we don't want that. So we're going to take negative 1. Oops, excuse me. I mean, we could think of it two ways, but anyway, negative 1 times row 2 plus row 3, replace it on row 3, right? And I'm going to write it right under there. It's a little bit of slacking on room, but that's okay. So row 3, so negative 1 times 0 plus 0 is 0. Negative 1 times 1 plus 1 is 0. Oh, and then 3 and the 3 and the 2 and the 2. Oh, I got my row of zeros finally. 0, 1, 3, negative 2, 2, negative 3, negative 13, 14. So I knew that was coming sooner or later. So a full row of zeros means there are many solutions. Okay, so what are we going to do now that we got our full row of zeros? Can we divide anything? I still did 0. On my notes, I still worked and did another 0 here, but I don't really think you have to. All right, so here's where I'm going to go. We know the first row is x1, x2, x3, and then kind of our answer. So I'm going to think of the first row as 2x1 minus 3x2 minus 13x3 equals 14. The second one now is going to be x2 plus 3x3 equals negative 2. And so I have these two ideas. So what they want you to do is to let t equal x3. So they have to give you that piece. They just pick another random letter. Okay, it's a little tricky. So on the bottom function, I am now going to replace x3 with t and solve that one in terms of x2. Okay, let me start this out like this. So I have x2 plus 3t equals negative 2. Why do they change it to a t? So they change it to another variable, really, because they want to say like x2 equals whatever number you pick, but it has to be in this format. So I'm going to minus that over. I'm basically going to say x2 equals negative 3t minus 2. And really, any number I want to put in for that t will get me the x2, the by multiplying by the negative 3 and minusing the 2. That will get me that value for x2. And so we know x3, we know x2 is going to equal this. Now, what is x3 going to equal? Oh, I already do. x2, x2, x1, excuse me. Does it make you do x1? Yeah, so x1 is now going to equal, well, I can't just write that. Okay, I want to think of this formula here. Okay, so I'm going to plug in the x2 and the t. So I have 2x1 minus 3, and instead of x2, I have negative 3t minus 2, and instead of x to the third, I'm going to have 13t equals 14. Okay, so let's take that line out. Then I'm just going to distribute that. Plus 9t plus 6 minus 13t equals 14. Add those t's together. And then I'm going to get, and then I want to move everything over so it's x1 equals. So I'm looking at this, I have negative 13 and I'd like to add 9, so I have negative 4. So I'm at 2x1 minus 4t plus 6 equals 14. And I want x1 equals. So I'm going to move everything over. So I'll start with the 6 because it can be combined with the 14. And now I'll move over here. So I'm going to have 2x to the first minus 4t equals 14 minus 6 is 8. And then I'm almost there. 2x1, add that over, and I get 8 plus 4t, or 4t plus 8, doesn't really matter. Divide everything by 2 every single term. So x1 is equal to 2t plus 4. Ew. So it needs to end up x1, x2, and x3. That is not easy. It's very time consuming, but it's basically, if you pick a value for x3, then you have to put that value into t to get x2 and into this to get x1. This is really, when we say we have many solutions, it really is restrictive to what is on that line or that function. And that's what this is saying. So in the past, we always just like, oh yeah, there's infinitely many solutions. They're actually pretty specific. They are on this line or they're on this graph. And we're just making you be more specific with your solutions. Okay, let's do a word problem. All right, so a dog food manufacturer makes 2 types of dog's food, Sparky's Special and Fido's Favorite Food. Each type of food uses 2 types of additives, additive 1 and additive 2. Each bag of Sparky Special selection has 7 units of additive 1, 6, oh my goodness, additive. Okay, so think of this in terms of, oh, where's that cool chart that I came up with? Oh. So think of this in terms of, we have Fido and Sparky. Oops. We have Fidos. Okay, and we have Sparkies. Okay, and then we have our additive. Okay, this is kind of the way I like to set it up. I have additive 1, and I have additive 2. Okay, and I have Fido, and I have Sparky. Fido and Sparky. So how much of does Fido need of additive 1? Each type of food, additive 1 and additive 2. Okay, each bag of Sparky's Special, so I'll do Sparky's first, had 7 units of this one and 6 units of this one. And Fido had 9 units of this one and 4 units of this one. Okay, and then it says, so I got that right? 9, 4. Yep. Okay, and then it says, on the last day of each month, dog manufacturer had 29 units of additive 1 and 42 units of additive 2 available. So we are looking at our total, right? Sometimes the total will be this way, And sometimes the total will be this way. It kind of depends on the problem. Well, this one tells you your total additive 1 is 209. Right? Yep, 209 additive 1 and 142 for additive 2. So what we're going to do is we'll just use F and S. I don't like using S, but we'll make it, maybe we'll just put a little like this on it or something so it doesn't look like a 5. So if we think about it, our formula can be right here. This is our function, one of our equations, and this is one of our equations. Had we had a total this way, we would have had an equation this way, and additive 1 and 2 could have been our variables. But on this one, it's Fidos and Sparkies and how much we can make of each. So we're going to go through and we're going to go like, okay, well, this is Fido, and this is Fido, and this is Sparky with the little weird symbol I'm going to use on my S so it doesn't look like a 5. And then the totals are on the bottom. So we're going to write those functions out as I need 9, excuse me, for F plus 7S will equal 209. And then the next one will be 4Fs plus 6 S's is equal to 142. And then we're going to solve this using and see how many bags of each type of dog food using a matrix. So I'm going to go, okay, 9, 7, 209, 4, 6, 142. I would like the 0, right, to be where the 4 and 7s are, and 1s where the other ones are, so I can see my solution. So not super pretty numbers, but that's okay. We can look at this and go, okay, if I times 9 by row 1 and add it to, I'm doing it backward. Excuse me, hang on. Not 9. Oh, goodness, I can't. I did it backward. I need 4 times row 1, right? Plus 9 or negative 9 times row 2. So my goal is times that by 4, that by 9, so that they both have a common number for us to get. And that will be replaced on, let's just replace it on row 2 so that we have that 0 under the 9 there. Okay, so if you don't like the 2 being multiplied, you can do this like multiply them both in one step and then add them together. I just got out my calculator and I just do my calculator as I go. So I think, okay, so 4 times 9 is going to give me 36. And then plus negative 9 times 4 is going to give me 0. I already knew that, but I still did it in my calculator just in case. So 4 times 7 for the next row, right? Minus 9 times 6 is giving me negative 26. I totally am using the calculator. So 209 times 4 minus 9 times 142. I got negative 442, right? I would like, does that divisible by 26? It is. I would like to simplify that. So we need our top row to stay the same. Do I have room? No, let me add a page real fast just because I definitely need more space. So when we look at this right now, 26 goes into both. And if that was a 1 already, it would make it easier for the next step. So we're going to divide row 2 by negative 26. And that's going to give me the 9, the 7, the 209. And then it's going to give me 0, 1, and 17. Okay. And then the next one, we want to 0 where the 7 is. Well, it's a lot prettier now. So we can take negative 7 times row 2, add that to row 1, replace that on row 1. And that'll give us a 0 where our 7 is. So let's do that. So negative 7 times row 2. Negative 7 times 0 is 0, plus 9 is 9. So I still have a 9 here. And then negative 7 times 1 plus 7 is going to give me a 0. And then I'm going to cheat. 17 times negative 7 is negative 119 plus 209 is 90. 0, 1, 17. Okay, so the top can be divisible by 10. Oops, 9, and the answer is 10. Like doing it in my head, spelled the wrong thing. So our final thing is this is a 1, 0, 10, 0, 1, 17. Okay, so we have to think about go back to the original, right? It went additive 1, it went Fido. Yeah, F, S. So row 1 was F and S because we wrote it out here, F, S. Just trying to make sure we know what's what. So Fido is 10 bags. And Sparky is 17 bags. Cool. All right. So I'm going to skip the next one. It's the same problem, but different. You could try that one. Let me give you the answer. The answer is 21 and 23. So so Sparky's is 21 and Fido's is 23. If I got those mixed, I think I just wrote a point 21, 23, but I think that's the way I did it. If you want to try that one on your own. So I am not under the illusion that these are easy, but I need you to learn this process because there's a lot harder matrices that have a lot of business outcomes that we need to learn. So this seems tedious as we learn it, but I want us to be able to start to look at XX hours in our business plan and our business model, or excess items for A and stuff like that, that we can use a matrix to solve. And that's where we're headed. So eventually I will show you some on the calculator, but for now I do need you to try it by hand so you're understanding how to do it. Okay, that was the end of my recording.